It was a quiet August night in 1977 when astronomer Jerry Ehman sat poring over pages of radio telescope data from Ohio State University's Big Ear Observatory. Then he saw it, a burst of signal so powerful, so unexpected, that he circled the reading in red ink and scribbled a single word next to it. Wow! That anomaly, lasting just 72 seconds, became one of the most tantalizing mysteries in the search for extraterrestrial intelligence. Decades later, we still don't know what caused it, but what if that wasn't just cosmic static? What if the wow signal was our first brush with something beyond Earth? The idea sends chills down the spine. Has humanity already made first contact, and we just didn't realize it? Think about that for a moment. A signal from the depths of space, carrying the faint echo of another civilization, perhaps reaching out, perhaps just passing by. The universe is unimaginably vast, with billions of galaxies, each home to countless stars. Statistically, we can't be alone. Yet here we are, straining our ears against the cosmic silence, waiting for a whisper. The wow signal might have been that whisper, slipping through our fingers before we could understand it. Scientists have debated its origins for years: natural phenomena, a glitch, or something far more profound. But what if the answer isn't buried in the past? What if the clues are right in front of us, hiding in plain sight? That's the journey we're taking today. We're diving into the enigma of the wow signal, peeling back layers of speculation and science to ask the boldest question of all: did we miss our moment of cosmic connection? From the depths of radio astronomy to the cutting-edge theories about interstellar messages, we'll explore every angle. Could the signal have been a beacon, a hailing frequency from a distant world? Or was it something even stranger, a fragment of a long-lost transmission, drifting through space for eons before brushing against our antennas? Strap in, because we're not just retracing history, we're reimagining it. And by the end, you might just look up at the night sky and wonder what's really out there. That signal, captured by the Big Ear telescope on August 15, 1977, wasn't just another blip in the cosmic noise. It was a narrowband radio burst screaming at a frequency of 1,420 MHz, a range scientists had long speculated might be used by extraterrestrial civilizations because it's one of the quietest parts of the electromagnetic spectrum, where natural interference is minimal. For 72 electrifying seconds, it blazed across the sky, coming from the direction of the constellation Sagittarius, then vanished without a trace. What made it unforgettable wasn't just its strength, but the way it behaved. Unlike pulsars or quasars, which flicker or fade predictably, this signal was clean, focused, almost engineered. Jerry Ehman's now famous red pen marked the raw day to print out with the letters and numbers 6EQUJ5, a code representing the signal's intensity over time. The numbers 0 through 9 tracked weaker readings, but letters A to Z, those meant something extraordinary. At its peak, the signal hit 30 times louder than the background noise of space, briefly becoming the loudest unexplained radio event ever recorded. And then silence, no repeats, no echoes, just that one tantalizing blip. Scientists rushed to point telescopes back at that patch of sky, but whatever sent that signal never spoke again. Here's the haunting part: everything about it fits the profile of an intentional transmission. Narrowband signals don't occur naturally, they're the hallmark of technology. The frequency, a cosmic waterhole, where hydrogen and hydroxyl molecules radiate, a logical place aliens might choose to broadcast. Even the duration matches expectations. 72 seconds is exactly how long the Big Ear telescope could fixate on one point in the sky as Earth rotated. It's as if someone out there timed it perfectly, knowing our instruments would catch it. But if it was a message, why only once? Was it a beacon sweeping past us like a lighthouse beam? A fragment of some long-dead civilization's final broadcast, or just a freak cosmic coincidence? decades later, we still don't have a definitive answer. Some argue it was a passing comet reflecting sunlight, except comets don't emit narrowband radio waves. Others suggest satellite interference, but none were transmitting at that exact frequency. The most unsettling possibility remains: we heard a voice just once and missed our chance to reply. Imagine standing alone in a dark forest, hearing your name whispered from the trees, and when you turn, there's only silence. That's the wow signal, a cosmic call with no callback number. Theories about the wow signal's origin span the spectrum from mundane to mind-blowing, each offering its own clues and contradictions. One of the most debated explanations points to comets. In 2016, astronomer Antonio Paris proposed that two passing comets, 266P Christensen and 335P Gibbs, might have been emitting hydrogen clouds as they neared the Sun, creating a brief radio spike. It's a tidy idea except for one glaring hole. Comets release broadband radio noise, not the razor-sharp narrowband signal Big Ear detected. Plus, those comets weren't even in the right part of the sky when the signal arrived. Like trying to fit a square peg into a round hole, the comet theory collapses under scrutiny. Then there's the interstellar hydrogen cloud hypothesis. Space is littered with swirling pockets of gas, and under just the right conditions, they could amplify radio waves from distant stars, acting like cosmic magnifying glasses. But here's the catch: such events would scatter signals across multiple frequencies, not concentrate them into a single laser-like burst. The wow signal was too clean, too precise, more like a tuning fork's pure note than the messy crash of cymbals. Which brings us to the elephant in the room: our artificial origin. SETI scientists have long argued that an intentional transmission would resemble exactly what Big Ear intercepted, a narrowband signal at a quiet frequency, engineered to stand out against nature's background static. Even the timing feels deliberate. 72 seconds matches Earth rotation relative to the telescope's fixed receiver, as if the sender knew exactly how our technology worked. Skeptics counter that space is vast and coincidences happen, but consider this: the odds of a natural phenomenon mimicking an ideal extraterrestrial beacon are astronomically low. Perhaps the most haunting twist comes from a study in 2022, suggesting the signal might have been a burst beacon, a one-time hail from a civilization intentionally signaling in all directions, knowing they'd never see a reply. It's a chilling thought. We might have intercepted a message meant for the universe, not for us, or worse, a farewell. Yet for all the theories, the wow signal defies easy answers. It's a cosmic riddle wrapped in static, daring us to keep listening, because somewhere out there, whether in Sagittarius or beyond, the truth is still waiting. Could the wow signal really have been our first hello from an alien civilization? To weigh that possibility, we have to wrestle with two of astronomy's biggest puzzles: the Fermi Paradox and the Drake equation. The Drake equation, dreamt up by astrophysicist Frank Drake in 1961, tries to estimate how many intelligent civilizations might be out there by factoring in variables like star formation rates and the odds of life emerging. Plug in optimistic numbers and the galaxy could be buzzing with voices. But here's where Fermi's famous question punches back: if intelligent life is common, why haven't we heard from anyone? That silence is deafening, which makes the wow signal so tantalizing. It fits the profile of a deliberate transmission almost too perfectly. Consider the design choices an advanced civilization might make. If you wanted to be heard across the cosmic static, you'd pick a frequency that cuts through the noise like the hydrogen line at 1420 MHz, where the wow signal pulsed. You'd aim for a narrowband signal, the radio equivalent of shouting through a laser beam instead of a foghorn. And if you knew other civilizations were listening with slow, Earth-rotating telescopes, you might send a burst time just long enough to be caught. The wow signal checks every box, but skeptics raise valid counterpoints. Space is weird. Natural phenomena often mimic artificial signals like pulsars, which fooled astronomers into dubbing them LGM for little green men when first discovered. Could the WOW signal be another cosmic false alarm? Then there's the billion-year timing problem. Even if civilizations exist, the odds of two emerging simultaneously within signaling distance are slim. A signal sent 10,000 years ago might arrive to find us still huddled in caves, or our ruins long dust. Yet buried in those uncertainties is a spine-tingling thought. The WOW signal came from the direction of Sagittarius, near the galaxy's dense core, a region packed with ancient stars where life could have had a multi-billion-year head start. What if we intercepted a relic from a civilization that's already gone? A single bottle tossed into the cosmic ocean, reaching us long after the sender faded. That's the haunting beauty of this mystery. Whether it's aliens or astrophysics, the WOW signal forces us to confront how little we truly know and how vast the possibilities are when we dare to listen. The moment the WOW signal faded into silence, the race to hear it again began. Astronomers scrambled to point every available telescope toward that same patch of sky near Sagittarius, hoping to catch another whisper from the void. But space, it seemed, had gone quiet. Over the next few decades, projects like SETI, the search for extraterrestrial intelligence, trained their arrays on that exact spot, scanning for even the faintest echo of that 72-second anomaly. They listened at the same frequency, 1,420 MHz, and across neighboring bands, just in case the signal had drifted. They monitored for patterns, for repetitions, for anything that might suggest a deliberate attempt at contact. Yet the cosmos offered only radio silence. This absence of a repeat is what makes the WOW signal so uniquely frustrating and fascinating. Most cosmic phenomena, from pulsars to solar flares, leave trails. They flicker, pulse, or reappear under predictable conditions, but it was a cosmic one-hit wonder. Imagine hearing a single, perfect note from a violin in a dark room, then never finding the musician. That's the torment of this mystery. Scientists have combed through historical data, wondering if earlier telescopes might have accidentally recorded a similar burst before 1977. They've even revisited modern observations, searching for overlooked blips that could be cousins of the WOW signal. So far, nothing. Theories about why it never repeated only deepen the intrigue. Some suggest it couldn't repeat, that it was a fleeting astrophysical event, like a neutron star's death rattle or a rogue asteroid's collision. Others argue it wouldn't repeat because it was never meant to. If it was an intentional transmission, perhaps the sender only broadcast once, sweeping the signal across the galaxy like a lighthouse beam, never pausing for a reply. There's a poignant irony here. The very things that made the WOW signal so compelling, its clarity, its precision, also make its isolation so baffling. Meanwhile, SETI work continues, sharper and more ambitious than ever. Modern telescopes like the Allen telescope array scan thousands of frequencies simultaneously, armed with algorithms that sift through cosmic noise in real time. Breakthrough Listen, a decade-long initiative, has dedicated millions of hours to monitoring millions of stars, including the WOW signal's neighborhood. Still, the original enigma stands untouched, a ghost in the machine of cosmic exploration. And that's the heart of it. The WOW signal isn't just a scientific curiosity. It's a mirror. Its silence forces us to confront how unprepared we might be for real contact. Could we have missed other signals, drowned out by Earth's own radio chatter? Are we listening wrong, or are we simply alone in the dark? Every unanswered scan sharpens the question, not just of what happened in 1977, but of what's still waiting to be heard. If the WOW signal wasn't an extraterrestrial broadcast, what could it have been? Scientists have spent decades testing every conceivable natural explanation, and while some come close, none fully explain the signal's eerie precision. Take hydrogen line emissions, a leading contender. In the cold depths of space, hydrogen atoms naturally emit faint radio waves at 1420 MHz, the exact frequency the WOW signal pulsed. At first glance, it's a perfect match, but there's a catch. Natural hydrogen emissions are broadband, spreading thinly across a range of frequencies. The WOW signal, by contrast, was razor-thin, occupying a sliver of bandwidth no wider than 10 kHz. That's like comparing the roar of a waterfall to the pure tone of a flute. Nature rarely produces such focused signals without help. Then there's the cosmic burst theory, flashes of radio energy from colliding neutron stars or evaporating black holes. These events can pack a punch, but they're messy, scattering energy chaotically across the spectrum. The WOW signal didn't just boom, it sang, holding its frequency with unnatural steadiness for 72 straight seconds. Even stranger, most cosmic bursts last milliseconds or repeat at intervals. The signal's one-and-done nature defies the usual rhythms of deep space fireworks. Instrumental error seems like an easy out. Maybe the telescope glitched. Yet Big Ear's twin receivers provided a reality check. Both antennas caught the signal, ruling out a local malfunction. And unlike earthly interference from satellites or aircraft, which leave telltale Doppler shifts as they move, the WOW signal's frequency held rock steady, as if anchored to the stars. The most compelling natural explanation might lie in a phenomenon called gravitational lensing. Massive objects like black holes can bend passing radio waves, amplifying distant signals like a cosmic magnifying glass. But lensing typically warps light, smearing signals across multiple frequencies. The WOW signal's clarity defies that distortion. It's as if someone took a natural explanation, polished away all its rough edges, and left behind something just a little too perfect. That's the needle astronomers keep threading. The signal's traits sit right on the edge of plausibility, nudging against the limits of known physics. Maybe it was a freak alignment of rare cosmic conditions, a once-in-a-billion-year fluke, or maybe, just maybe, it was something else entirely. The universe has a habit of outsmarting our assumptions. After all, before pulsars were discovered, their precise beats were nearly mistaken for alien Morse code. The WOW signal could be another cosmic joke or the first clue in a galactic puzzle we're only beginning to piece together. The 1420 MHz frequency of the WOW signal wasn't just a random blip on the cosmic dial. It was a cosmic landmark, a frequency as fundamental to the universe as a heartbeat. Scientists call this the hydrogen line, and it's no accident that this particular slice of the radio spectrum would catch an astronomer's eye. Hydrogen, the simplest and most abundant element in the cosmos, sings here. Every lonely hydrogen atom drifting between the stars naturally emits faint radio waves at this exact frequency as its electron spins down. That makes 1420 MHz the universe's background hum, a frequency so universal that any civilization with radio technology would inevitably stumble upon it. Think of it like this: if aliens were trying to hail us, they wouldn't send a message on some obscure static choke channel. They'd pick the clearest, most obvious frequency in the galactic playlist, and that's exactly what the hydrogen line offers. It's the interstellar equivalent of two strangers agreeing to meet under the only visible clock in a train station. Back in 1959, physicists Giuseppe Cocconi and Philip Morrison first proposed this idea in their groundbreaking paper, suggesting that 1420 MHz would be the natural watering hole for civilizations to gather and listen. The WOW signal didn't just drift into this frequency, it marched straight to the center of the dance floor. But here's where it gets even stranger. That frequency isn't just quiet and universal, it's also protected. Governments and scientists have informally agreed to avoid broadcasting here, preserving it as a sacred channel for cosmic eavesdropping. Radio interference from Earth barely touches this range, making it an oasis of silence in our noisy electronic age. So when the wow signal erupted at 1420 MHz, it wasn't just loud, it was pristine, as if someone had deliberately chosen the one frequency where they'd stand out against the universe's natural whisper. Yet this same elegance raises haunting questions. If a civilization was trying to signal us, wouldn't they add something? A pattern, a pulse, a mathematical constant, to scream artificial? The wow signal carried no such obvious signature. Its simplicity cuts both ways. It's either the perfect cosmic hello, stripped down to its purest form, or a freakishly precise natural phenomenon we still don't understand. Perhaps the most unsettling possibility is that we're missing the message's true form. Imagine an ancient human finding a smartphone. They might recognize it as a crafted object, but the glowing symbols on its screen would mean nothing. Could the wow signal's frequency itself be the message, a beacon saying, "Listen here," while the real content lies hidden in some layer we haven't learned to decode? After all, hydrogen is the building block of stars, planets, and life itself. Broadcasting at its frequency isn't just practical, it's poetic. The hydrogen line ties the wow signal to one of astronomy's deepest truths. The universe speaks in a language of physics, and 1420 MHz is one of its mother tongues. Whether the signal was a handshake from the stars or the cosmos playing a prank, its choice of frequency ensures we'll never stop wondering what or who might be tuning in. Jerry Ehman wasn't looking for aliens that night. A quiet, methodical researcher with a background in physics and astronomy, he was simply volunteering to sift through reams of radio telescope data as part of Ohio State's SETI efforts. The printouts he pored over were unremarkable columns of numbers and letters representing cosmic noise until he reached one line that made his pulse quicken. The sequence 6EQJ5 blazed off the page, a string of characters so unusual that Ehman instinctively grabbed his red pen and circled it. Then, in the margin, he scrawled the word that would echo through history: wow. In that moment, he wasn't a scientist analyzing data. He was a human being struck by the sheer wrongness of what he was seeing. Ehman's famous annotation wasn't just a label, it was a visceral reaction to something that defied expectation. Years later, he'd confessed that his handwriting in that moment betrayed his shock. The exclamation point dug deeper into the paper than the rest. Yet for all his excitement, Ehman remained a skeptic at heart. He spent decades insisting the signal demanded rigorous scrutiny, not wild speculation. Extraordinary claims require extraordinary evidence, he'd often say, paraphrasing Carl Sagan. Even as the wow signal became a cultural icon, Ehman resisted the urge to call it proof of ET. To him, it was simply the most tantalizing maybe in astronomy. His humility only deepened the mystery. Unlike some researchers who might have clung to their moment of fame, Ehman seemed almost haunted by the signal's unresolved nature. In interviews, he'd ponder alternatives: a reflected satellite transmission, an overlooked celestial event, but always circled back to the same quiet awe. "It's the only thing in my career that ever gave me goosebumps," he admitted. That blend of skepticism and wonder defined Ehman's legacy. He never claimed to have found aliens, but he never dismissed the possibility either. Instead, he became a guardian of the question, reminding the world that science isn't just about answers, it's about learning how to ask better questions. Decades after that red pen moment, Ehman's reflections took on a poignant tone. "I sometimes wonder," he mused in 2010, "if future generations will solve this puzzle and laugh at how close we were, or if they'll still be staring at the same static just as puzzled." His words capture the duality of the wow signal, a beacon of hope for contact and a mirror for our own cosmic loneliness. Ehman passed away in 2022, leaving behind a single circled annotation that outshone his lifetime of academic work. Perhaps that's the signal's greatest power, not as proof of others, but as proof of our own yearning to reach beyond the silence. the WOW signal didn't just captivate scientists, it seeped into the collective imagination, becoming a cultural shorthand for humanity's hunger to connect with the cosmos. Within years of its discovery, references began popping up in science fiction, from novels like Carl Sagan's Contact to blockbuster films that depicted mysterious radio transmissions as gateways to first contact. The signal's eerie blend of scientific legitimacy and unresolved mystery made it irresistible to storytellers. It wasn't just a data point, it was a narrative lightning rod embodying our deepest hopes and fears about what might be lurking in the void. Conspiracy theorists latched onto it with particular fervor, weaving elaborate tales of government cover-ups and suppressed alien dialogues. Some claimed the signal was a distress call from a dying civilization. Others insisted it was a test by an advanced species gauging our readiness for contact. Online forums erupted with pseudoscientific decoding attempts, with amateur cryptographers insisting the signal's intensity spikes spelled out mathematical constants or even star coordinates. The more mainstream science dismissed these claims, the more the WOW signal became a rallying cry for those convinced the truth was being hidden, but its cultural footprint extended beyond fringe circles. Musicians sampled its radio wave patterns into ambient tracks, artists embedded its alphanumeric sequence, 6EQUJ5, into installations, and tech companies borrowed its aesthetic for ads selling the promise of cosmic connection. The signal even infiltrated politics. When the US government declassified limited UFO reports in 2020, social media erupted with memes comparing them to the WOW signal, another cosmic hello we're ignoring, one viral post quipped. Perhaps its most profound impact was on SETI itself. Before 1977, the search for extraterrestrial intelligence was a niche academic pursuit. After Ehman's red pen marked that printout, public funding and interest surged. The signal became SETI poster child, proof that the universe might still surprise us. Crowd-funded projects like the Allen Telescope Array owe their existence in part to the cultural momentum the WOW signal generated. It transformed alien hunting from pulp fiction fodder into a legitimate scientific endeavor, one that could at any moment stumble upon another WOW. Yet for all its influence, the signal's legacy is bittersweet. It's a reminder of how rarely reality delivers the satisfying arcs of fiction. No sequel ever arrived, no hidden message was decoded. The WOW signal endures not as an answer, but as a question etched into pop culture, a single, unresolved chord in humanity's symphony of curiosity. The moment the WOW signal blipped onto astronomers' radar, it didn't just intrigue scientists, it sent ripples through the shadowy corridors of military and government agencies. While no smoking gun document explicitly ties officials to the signal, declassified records reveal a pattern of hushed curiosity. Project Blue Book, the U.S. Air Force's infamous UFO investigation unit, had officially closed its doors by 1977, but its legacy of monitoring unexplained aerial phenomena didn't vanish overnight. Whispers among SETI researchers suggest that classified briefings were held, with telescope data scrutinized by intelligence analysts. One former Air Force officer, speaking anonymously in a 2012 interview, claimed the signal triggered a quiet flurry of activity at Wright-Patterson Air Force Base, home to Blue Book's archives, though no paper trail confirms this. The military's potential interest isn't paranoia, it's precedent. During the Cold War, both American and Soviet agencies monitored space for anomalous radio emissions, fearing they might mask enemy signals or, worse, extraterrestrial threats. A 1979 memo from the Defense Intelligence Agency, later unearthed via FOIA requests, listed non-terrestrial electromagnetic anomalies as a category requiring routine surveillance. While the WOW signal isn't named, its timing and profile fit the description. Even NASA, typically transparent with astrophysical data, reportedly delayed releasing certain Big Ear telescope logs for months, a hiccup some researchers found suspicious. Then there's the tantalizing, if unverified, link to signal's intelligence. In the late 70s, the National Security Agency operated a global network of listening stations designed to intercept Soviet communications. Some conspiracy theorists argue these stations, tuned to similar frequencies, might have caught the WOW signal independently. A cryptic 1978 NSA document titled Interstellar Radio Frequency Anomalies was partially declassified in 2004, its pages heavily redacted. The few legible lines mention narrowband emissions of unknown origin, fueling speculation. Skeptics counter that the NSA monitored earthly transmissions, not deep space, but in the intelligence world, boundaries blur. What's undeniable is the Pentagon's later fascination with UAPs, unidentified aerial phenomena. Recent congressional hearings and declassified Navy footage of unexplained objects reignited debate about whether agencies had been sitting on cosmic clues for decades. Retired CIA physicist Hal Puthoff, who spearheaded the Pentagon's Advanced Aerospace Threat Identification Program, admitted in 2017 that his team revisited historical anomalies, including certain 1970s radio events, though he stopped short of naming the WOW signal directly. The dots may not connect neatly, but they trace a compelling silhouette. Wherever ambiguity lingers, governments lean in. Perhaps the most telling detail is what's missing. Despite the WOW signal's fame, no military or intelligence agency has ever published an official analysis, an absence that speaks volumes. In the intelligence community, silence isn't indifference, it's a strategy. Whether the signal was filed away as a curiosity or a priority may remain locked in some vault, but the pattern is clear. When the cosmos whispers, someone in uniform is usually listening. The Big Ear telescope that caught the WOW signal in 1977 was a technological marvel for its time, but by today's standards it was practically prehistoric. Picture this, a sprawling rectangular metal mesh the size of 3 football fields, fixed to the ground, relying entirely on Earth's rotation to scan the sky. It had no moving parts, no digital signal processing, just a simple receiver logging data onto paper printouts. Compare that to modern arrays like the Allen Telescope in California or China's colossal FAST dish, where hundreds of precision-steered antennas work in concert, backed by supercomputers analyzing millions of frequencies simultaneously. The difference isn't just incremental, it's like comparing a sundial to an atomic clock. Back then, detecting the WOW signal was akin to hearing a single chime in a thunderstorm. Big Ear's receivers could only monitor 50 channels at once, leaving vast swaths of the radio spectrum unobserved. Today's instruments scan billions of frequencies in real time, filtering out interference with machine learning algorithms that would have seemed like science fiction in the 70s. Modern telescopes also have something Big Ear sorely lacked: memory. That 72-second signal was only recorded as a scribble on paper, with no raw data preserved for deeper analysis. Now, every blip and murmur from the cosmos gets stored in petabyte-scale databases, allowing scientists to revisit anomalies years later with new techniques. Sensitivity is another quantum leap. Big Ear's detection threshold was roughly 30 times the background noise, impressive then, but laughably crude now. Contemporary arrays like the Very Large Array in New Mexico can pick up signals 10,000 times fainter, the equivalent of hearing a whisper across a crowded stadium. They're also immune to many false positives that plagued older systems. Earth radio interference, cell towers, satellites, even microwave ovens now gets digitally subtracted in real time, leaving only pristine cosmic data. Had the WOW signal hit today, we'd know instantly whether it came from Sagittarius or a passing satellite. Perhaps most crucially, modern telescopes never sleep. Big Ear listened to any given patch of sky for just 72 seconds before Earth's rotation carried it out of view. Today's networked observatories monitor promising regions around the clock, with automated alerts pinging astronomers' phones if something unusual appears. Projects like Breakthrough Listen can simultaneously track 1,000 stars, revisiting each dozens of times, a stark contrast to the one-shot wonder of the WOW detection. Yet for all these advances, one haunting question remains. Would we even recognize a repeat? The universe is vast, and signals might encode information in ways we haven't imagined. Modern SETI now searches not just for narrowband pings, but for pulsed lasers, quantum-entangled photons, even neutrino bursts. The WOW signal's greatest legacy might be teaching us how much we still have to learn. There's a poignant irony here. As our technology races forward, that fleeting 1977 signal grows fainter in another way, receding into history, still defiantly unexplained. We've built telescopes that can hear a meteorite land on Pluto, yet that one perfect cosmic whisper remains alone in the archives. Maybe the next WOW is already in our data, waiting for the right algorithm to tease it out. Or maybe, just maybe, the universe was playing a trick on us, one that even 21st century science can't quite unravel. Today's search for extraterrestrial intelligence barely resembles the patchwork efforts of the 1970s. Projects like Breakthrough Listen represent a quantum leap in capability, deploying cutting-edge technology that would have seemed like science fiction when the WOW signal first crackled through Big Ear's rudimentary receivers. With funding from Silicon Valley billionaires and access to some of Earth's most powerful telescopes, this modern hunt for cosmic companions is rewriting the rules of the game. At its core, Breakthrough Listen operates on a staggering scale, monitoring millions of stars across billions of radio frequencies simultaneously. Where astronomers once painstakingly adjusted dials by hand, AI-driven algorithms now sift through petabytes of cosmic noise in real time, flagging anomalies human operators might miss. The program's crown jewel is the Meerkat array in South Africa, 64 interlinked dishes working in concert to scan the entire galactic plane with unprecedented precision. Unlike the static Big Ear telescope, these steerable antennas can pivot instantly to investigate anything unusual, tracking targets across the sky for hours or days if needed. The data processing alone boggles the mind. Breakthrough's servers analyze 10 gigahertz of bandwidth every second, equivalent to downloading 5,000 high-definition movies simultaneously, while machine learning models filter out earthly interference with surgical precision. Where the WOW signal's origins were clouded by potential satellite contamination, modern systems automatically cross-reference every detection with orbital traffic logs, weather patterns, even passing aircraft. False positives still occur, but they're weeded out within milliseconds rather than debated for decades. Perhaps most revolutionary is the program's commitment to open science. Every anomaly gets catalogued in public databases, inviting astronomers worldwide to scrutinize potential signals. This transparency contrasts sharply with the opaque government projects of the Cold War era, reflecting a fundamental shift in how humanity approaches the cosmic search. The team even developed a SETI cocktail party algorithm that isolates promising signals from background noise. Imagine picking out one whispered conversation across a packed stadium. Yet for all this technological firepower, the philosophy remains elegantly simple. Listen first, theorize later. Breakthrough Listen casts an unprecedentedly wide net, scanning not just the hydrogen line but thousands of adjacent frequencies where alien engineers might have parked their broadcast. They're even monitoring brief laser pulses, optical SETI, on the chance that advanced civilizations might prefer light to radio waves. The project's sheer ambition sometimes borders on poetic. One initiative, dubbed Listen Nearby, examines the 1,000 closest stars with painstaking detail, while another scans the entire Milky Way's plane in broader strokes, like searching your hometown with a magnifying glass while simultaneously surveying the whole country through binoculars. Early results already include intriguing candidates, like 1,620 unexplained narrowband signals detected during a survey of galactic center. None have repeated yet, but each gets logged for future follow-up. What makes these modern efforts so compelling isn't just their scale, but their humility. Scientists acknowledge they might be searching wrong, that alien communication could employ quantum encryption, gravitational waves, or mediums we haven't yet imagined. So alongside traditional methods, Breakthrough funds speculative research into neutrino messaging and other exotic possibilities. It's this blend of vast resources and intellectual flexibility that defines 21st century SETI, less a single experiment than a sprawling, adaptive conversation with the cosmos. The WOW signal's legacy looms large over all this activity. Modern searchers routinely revisit its original coordinates near Sagittarius, applying tools big ears operators couldn't have dreamed of. Some astronomers half-joke that should they detect a repeat, the entire astronomical community might collectively scribble "WOW" in digital margins before promptly crashing every telescope onto that patch of sky. But the real triumph of projects like Breakthrough Listen lies in their refusal to treat the WOW signal as an endpoint. Instead, they've transformed it into a stepping stone proof that the universe still holds surprises, and that with enough patience and ingenuity, we might one day hear more than just a cosmic dial tone. After all, if a flimsy Ohio telescope could stumble upon such a profound mystery, what might our planet-spanning arrays uncover now that we're truly listening? That faint blip of radio waves from Sagittarius didn't just come from anywhere. It erupted near a star cluster catalogued as Chi Sagittarii, roughly 150 light-years from Earth. Picture this region not as a blank spot on the map, but as a bustling stellar neighborhood. Chi Sagittarii itself is a binary system, two stars locked in a gravitational dance orbited by at least 3 gas giants. But here's the catch: these worlds are inhospitable giants, more akin to Jupiter than Earth. So if something intelligent sent that signal, it likely wasn't from there. The real intrigue lies in the surrounding cosmic real estate. Within a 50 light-year bubble of the WOW signal's origin point, astronomers have identified over 400 stars, many with planetary systems still being mapped. One standout is a dim red dwarf designated Ross 154, just 9 light-years from the signal's apparent source. Red dwarfs are notorious for hosting rocky planets snug in their habitable zones where liquid water could exist. Ross 154's planetary lineup remains unconfirmed, but statistical models suggest a high probability of Earth-sized worlds. Even more compelling is 289G Scorpii, a Sun-like star with 2 confirmed exoplanets, one a super-Earth parked comfortably in the Goldilocks zone. While we've found no direct evidence of life there, it's precisely the kind of place where a civilization might arise given enough time. Then there's the galactic context. Sagittarius isn't just another constellation, it points toward the Milky Way's dense core, where stars pack together like a celestial metropolis. This region is ancient, teeming with stars billions of years older than our Sun. If intelligence emerges more readily in older stellar environments, the WOW signal's origin zone becomes profoundly significant. A civilization here could have had a multi-billion-year head start on us, perhaps mastering technologies that seem like magic. But distance complicates everything. The signal's estimated 150 light-year journey means it left its source around the time Charles Darwin was drafting on the origin of species. Any civilization there would have had no way to know humans had industrialized, let alone developed radio telescopes. This raises eerie possibilities. Were they blindly broadcasting to the void, hoping someone might evolve to hear it? Or was the signal never meant for us at all, just a cosmic flare gun shot sideways through the galaxy? Modern telescopes are now scouring these stars for biosignatures, chemical fingerprints like oxygen or methane that hint at life. Breakthrough Listen has prioritized this patch of sky, hunting for repeating signals or structured transmissions. So far, silence, yet the sheer density of promising stellar targets near the WOW signal's coordinates keeps astronomers vigilant. every time a new exoplanet is confirmed in this region, the same whispered question follows. Could this be the address of whoever or whatever reached out that August night in 1977? The coordinates linger as both a clue and a taunt. In a galaxy where most stars are too young or unstable for life, this particular corner of Sagittarius checks nearly every box for potential intelligence. Until we scan every candidate or receive a second signal, the mystery remains suspended, a cosmic what-if drifting between the stars. The idea that the WOW signal might have come from a human satellite seems plausible at first glance. After all, the late 1970s were a golden age of space exploration, with dozens of probes and satellites buzzing around Earth. But dig into the physics and this theory crumbles faster than a sandcastle at high tide. For starters, satellites don't behave the way the WOW signal did. Artificial objects in orbit move predictably, tracing graceful arcs across the sky as they obey Newton's laws. The signal, by contrast, appeared fixed against the background of stars, drifting through Big Ear's detection beam at exactly the rate you'd expect for a celestial object anchored to the cosmos, not something zipping around Earth at thousands of miles per hour. Then there's the frequency problem. The WOW signal pulsed at 1,420 MHz, a sweet spot in the radio spectrum where hydrogen naturally sings. Satellites, though, they're chatty on entirely different frequencies. Military and scientific satellites of the era typically broadcast in the L-band, around 1 to 2 GHz, or the S-band, near 3 GHz, nowhere near the hydrogen line. Even if one had strayed off frequency, satellites produce broadband noise, not the laser-focused narrowband spike Big Ear detected. It'd be like mistaking a foghorn for a flute solo. Timing adds another nail to the coffin. Big Ear's twin receivers, spaced apart to weed out local interference, both caught the signal with identical intensity. A satellite close enough to blare that loud would have shown Doppler shifting, a telltale warping of frequency as it moved toward or away from the telescope. Yet the WOW signal's frequency held rock steady, as if carved into the fabric of space itself. Perhaps the most damning evidence comes from the orbital logs. Researchers later cross-referenced the signal's timing and direction with records of every known satellite in 1977. None were anywhere near Sagittarius when the WOW signal hit. Even classified military satellites, whose existence was confirmed decades later, couldn't account for it. Their orbits didn't align. So unless there was a top-secret, hyper-advanced satellite defying known physics, one that somehow mimicked the signature of an interstellar transmission, the human-made explanation doesn't hold up. The WOW signal came from somewhere much, much farther away, and that's what makes it so endlessly fascinating. 46 years of silence stretch between us and that electrifying 72-second burst from Sagittarius. A void so profound it makes astronomers whisper the unthinkable. Was the WOW signal not just rare but singular? Modern SETI scans 100 million times more data annually than Big Ear could process in its entire lifetime, yet not one anomaly has matched its eerie perfection. This absence gnaws at the edges of scientific consensus, splitting researchers into two camps. Some insist the signal was a statistical inevitability, the universe's version of rolling a Yahtzee on the first throw, never to be repeated. Others see darker implications. What if we intercepted a message never meant to be heard twice? Consider the numbers. Breakthrough Listen has analyzed over 1,000 nearby stars with 10 times the sensitivity of 1977's technology, hunting for anything resembling the WOW signal's fingerprint. The result, cosmic white noise. Statisticians calculate that if such signals occurred randomly, we should have caught at least a dozen by now. Their absence suggests either astounding bad luck or that the WOW event wasn't random at all. This silence fuels provocative theories. Perhaps the signal was a one-time beacon, a civilization's desperate SOS before collapse. Ancient Egyptian hieroglyphs or Mayan codices endured millennia after their creators vanished. Could the WOW signal be a radio wave Rosetta Stone from a now-dead world? Alternatively, maybe it was a targeted burst aimed elsewhere, and Earth merely stood in the beam's path for one fleeting instant, like a pedestrian momentarily illuminated by a searchlight sweeping distant hills. Then there's the chilling possibility of intentional silence. The zoo hypothesis suggests advanced civilizations might deliberately avoid contact, observing us as we would animals in a wilderness preserve. In this scenario, the WOW signal could have been a slip, a momentary breach of protocol before some cosmic park ranger switched off the transmitter. Yet for all these speculations, the simplest explanation remains unnerving. Space is unimaginably vast, and even with trillions of stars, civilizations might be spaced so far apart that signals rarely overlap. The WOW signal could have been our one brush with the cosmic lottery, a message in a bottle that took 150 years to reach shore, with no others following. Until we build telescopes sensitive enough to scan every star in the Milky Way in real time, we're left straining to hear an echo that may never come. The silence isn't empty, though. It's a mirror reflecting back our own assumptions about how aliens might communicate. We search for radio waves because that's the technology we understand, but what if advanced civilizations moved on millennia ago to neutrino pulses or quantum entanglement? The WOW signal's legacy isn't just about what we heard in 1977, but what we've failed to hear since, and that failure might be the most important message of all. The WOW signal doesn't exist in a vacuum. It's part of a much larger puzzle that astrobiologists have been piecing together for decades. Where does life emerge in the universe? How often does it evolve into something capable of reaching out across the stars? These aren't just philosophical musings, they're questions with real stakes, and the answers are shaping how we search for cosmic neighbors. When that mysterious pulse arrived from Sagittarius, it landed right in the middle of a revolution in our understanding of life's potential. Take exoplanets for starters. In 1977, the year of the WOW signal, we knew of exactly 0 planets beyond our solar system. Today, NASA catalogs swells with over 5,000 confirmed worlds, and statistical models suggest the Milky Way alone harbors hundreds of billions more. Many of these aren't just gas giants, they're rocky, Earth-sized planets nestled in habitable zones where liquid water could pool. The TRAPPIST-1 system, 39 light-years away, packs 7 such worlds into orbits tighter than Mercury's. 3 of them sit in the Goldilocks zone with conditions that might resemble early Earth. Then there's Kepler 438b, a planet 1,200 light-years distant with a 60% chance of being rocky, bathed in starlight eerily similar to our Sun's. But habitability is more than just location. Astrobiologists now recognize that life might thrive in environments we once thought barren. Subsurface oceans on icy moons like Europa and Enceladus, heated by tidal forces, could host microbial ecosystems entirely cut off from sunlight. Methane lakes on Titan might cradle exotic life forms built on chemical blueprints alien to Earth. Even Venus, with its crushing atmosphere and acid clouds, has shown flickers of potential phosphine gas in its upper layers, a possible signature of microbial metabolism. The universe, it seems, is far more inventive with habitats than we ever imagined. This explosion of possibilities reshapes how we interpret signals like WOW. If life can arise in so many environments, why wouldn't intelligence follow? On Earth, complex cognition evolved only once in 4 billion years, but in a galaxy with more planets than grains of sand on every beach, odds tilt toward repetition. Some astrobiologists argue that intelligence might even be a cosmic inevitability, given enough time and stable conditions. Others counter that while microbial life could be common, technological civilizations might be vanishingly rare, separated by gulfs of time and space so vast they almost never overlap. The WOW signal sits at the heart of this debate. Its very existence, whether natural or artificial, forces us to confront how little we truly know about life's cosmic footprint. Every new exoplanet discovery stretches the boundaries of possibility, but also underscores how much remains unseen. We've gone from assuming we're alone to suspecting the universe teems with life, yet we still can't say whether any of it is waving back. Perhaps the most profound lesson lies in humility. For all our telescopes and algorithms, we're still like children holding seashells to our ears, mistaking the roar of the ocean for a distant voice. The wow signal, whether it was a cosmic hello or just the universe sighing, reminds us that the search has only just begun, and the answers, when they come, might rewrite everything we think we know. If the wow signal had carried an artificial message, how would we even begin to decipher it? Scientists have spent decades preparing for this very scenario, developing theoretical frameworks to crack an interstellar code. The challenge is staggering. We'd be confronting a language with no shared history, no common culture, not even a guarantee that the sender perceives reality the same way we do. Yet hidden in that alien static might be universal keys, mathematics, physics, the fundamental constants that bind the cosmos. First, researchers would hunt for structure. Natural radio emissions meander like static hiss, but an engineered signal could reveal deliberate patterns repeating prime numbers, Fibonacci sequences, or ratios like pi woven into its pulses. These mathematical signatures wouldn't just scream artificial, they'd provide a Rosetta Stone. In 1974, the Arecibo message beamed toward the stars encoded basic human knowledge in binary, from DNA's double helix to our solar system's layout. An advanced civilization might employ similar principles, using math as a lowest common denominator. But what if the message wasn't just a beacon, but a lexicon? Enter Linkos, a conceptual language crafted by mathematician Hans Freudenthal in the 1960s. Designed for cosmic pen pals, Linkos starts with simple arithmetic transmitting pulses that teach 1 + 1 = 2, then builds toward complex ideas through incremental logic. A signal like wow could contain such a tutorial, beginning with counting exercises before introducing chemistry, astronomy, even abstract concepts like time or emotion. The real test wouldn't be recognizing the language, but figuring out its accent. Would they represent hydrogen's atomic weight as a vibration count or a geometric shape? Some theorists propose more radical decryption methods. A civilization capable of interstellar communication might embed information in higher dimensions, folding data into the signal's polarization or quantum fluctuations. The wow signal's 72-second duration could itself be a clue, perhaps divisible into chunks that form a raster image when stacked, or harmonics that reveal a 3D structure when played at specific speeds. Harvard's Avi Loeb once speculated that advanced beings might transmit via neutrino bursts or gravitational waves, leaving radio as mere post-it notes for primitive species like us. The darkest possibility: we've already missed the message. The wow signal's purity, that razor-sharp frequency, might have been the envelope, not the letter. What if the real content hid in subtle modulations, requiring quantum decryption or computational power we won't possess for centuries? Like cabbages finding a smartphone, we might stare at the glowing surface without grasping the libraries beneath. Yet the search continues. SETI's latest algorithms don't just listen for beeps, they analyze signal morphologies for embedded data structures, hunting for layers we couldn't perceive in 1977. Machine learning now sifts through noise for statistical anomalies that might represent multi-dimensional encoding. If another wow arrives, we'll be ready not just to hear it, but to listen. Because the greatest message might not be in the signal itself, but in the simple, shattering proof that we're not shouting into the void alone. Among the countless theories swirling around the wow signal, some insist it was nothing more than an elaborate hoax, a prank slipped into the data logs to fool overeager astronomers. These claims often point to Jerry Ehman's famous red pen notation as potential proof of human meddling. Why else, skeptics ask, would a respected scientist react with such unscientific exuberance? But this argument crumbles under scrutiny. Ehman wasn't some wide-eyed amateur. He was a trained physicist with a reputation for meticulous analysis. His wow annotation wasn't a declaration of alien contact. It was an instinctive reaction to data that defied every expectation. The idea that he'd fabricate a discovery in a field where credibility is everything makes little sense. Besides, the signal wasn't just scribbled on a napkin. It was recorded simultaneously by Big Ear's twin receivers, eliminating the possibility of a local glitch or tampering. Another persistent myth suggests the signal was misinterpreted natural interference, perhaps a military transmission or a secret spy satellite bleeding into the telescope's frequency. But declassified records show no known human-made signals matched the WOW signal's profile in August 1977. Military satellites of the era operated on completely different bands, and their transmissions would have shown Doppler shifts as they moved across the sky. The WOW signal, by contrast, remained locked to a single frequency with surgical precision, drifting at exactly the rate expected for a fixed cosmic source. Even classified projects like the NSA's listening stations, which monitored similar frequencies for intelligence purposes, have no record of active broadcasts that align with the signal's timing or location. Then there's the reflected signal theory, the notion that some earthly transmission bounced off space debris or the moon, creating a false interstellar echo. At first glance, it's plausible. After all, radar signals from the Arecibo Observatory routinely ping off asteroids, returning hours later as faint echoes. But the math doesn't add up. For a reflected signal to mimic the WOW signal's characteristics, it would have needed to originate from an impossibly powerful transmitter, something far beyond 1970s technology. Even NASA, a deep space network with its gargantuan dish antennas, couldn't accidentally produce a burst that intense. And why would a reflected signal appear only once in a part of the spectrum carefully avoided by terrestrial broadcast? The scientific community dismisses these hoax theories for one simple reason: the signal's purity. Its narrowband focus, its perfect alignment with the hydrogen line, its 72-second duration matching Earth's rotation. These aren't traits easily faked or coincidentally replicated. Nature rarely produces radio emissions so pristine, and human technology at the time couldn't have engineered them without leaving obvious fingerprints. That's why, despite decades of searching, no terrestrial explanation has ever fit all the evidence. The WOW signal remains an outlier, a cosmic Rorschach test that says as much about our desire for easy answers as it does about the mysteries still lurking in the stars. Perhaps the most telling detail lies in what happened after that night. Big Ear's operators didn't just file the data away. They spent years methodically ruling out every possible prosaic explanation, from equipment malfunctions to atmospheric anomalies. Subsequent observations with more sensitive telescopes never found a repeat, but they also never found a smoking gun pointing to human interference. In science, extraordinary claims require extraordinary evidence, but the absence of a mundane explanation can be just as compelling. The WOW signal endures not because it's been debunked, but because against all odds it hasn't, and that's a mystery worth keeping alive. The WOW signal stands apart from the swirling sea of UFO sightings in one crucial way: it left behind hard data. Unlike fleeting lights in the sky or grainy photographs debated for decades, this 72-second radio burst was captured on paper, its intensity meticulously recorded by calibrated instruments. That printout, with Jerry Ehman's now iconic red pen circling 6EQUJ5, became a tangible artifact that scientists could analyze, replicate, and debate using the rigorous tools of astrophysics. UFO reports rely on eyewitness testimony, distortion-prone cameras, and the quirks of human perception. the wow signal, it was mathematics etched onto paper, a waveform frozen in time. Yet despite this gulf in credibility, both phenomena tap into the same profound human question: are we alone? The difference lies in how they approach the answer. UFO sightings thrive on ambiguity. The blurrier the image, the more room for interpretation. The wow signal, by contrast, gains its power from precision. Its narrowband frequency, cosmic origin point, and clean intensity curve make it a puzzle that fits uncomfortably well with theories of intentional transmission. Scientists can't dismiss it as swamp gas or weather balloons. They have to wrestle with its anomalies using spectral analysis and radio astronomy. This tension between mysticism and methodology shapes how both topics are treated. UFO discourse often lives in the fringes, fueled by conspiracy theories and government secrecy. The wow signal, while equally mysterious, resides in peer-reviewed journals and conference presentations. When researchers debate its origins, they cite hydrogen line emissions and telescope beam widths, not crashed saucers or alien autopsies. That scientific framing gives it staying power. 46 years later, astronomers still design experiments hoping to catch another whisper like it. But the human mind craves connection, and it's no accident that the wow signal has been adopted by UFO enthusiasts as a smoking gun. Both speak to our longing for cosmic companionship, just in different languages. Where UFO stories offer visceral immediacy, they're here. The wow signal whispers a more haunting possibility. They were there. That distinction matters. A UFO might land on the White House lawn tomorrow, but the wow signal suggests something more melancholic and profound. Intelligence flickering briefly across the gulf of space and time, perhaps already gone before we even looked up. The irony is rich. For all their differences, both UFOs and the wow signal end up pointing to the same existential horizon. One does it with Hollywood flair, the other with the cold elegance of mathematics. But in a universe that may be stranger than we can imagine, perhaps both are fragments of a truth we're only beginning to grasp. What if we could reply to the wow signal? Should we? This question splits the scientific community down the middle, sparking one of the most heated ethical debates in modern astronomy. On one side, initiatives like SETI, Messaging Extraterrestrial Intelligence, argue that silence isn't just cowardice, but a missed opportunity for cosmic connection. Their logic is bold. If we're listening for alien signals, why wouldn't they be doing the same? Projects like the Arecibo message in 1974 and the more recent beacon in the galaxy transmission have already sent coded greetings into the void, encoding everything from DNA structures to mathematical constants. To SETI advocates, these aren't reckless shouts into the dark. They're handshakes extended across the stars, invitations to a conversation that could elevate humanity's place in the universe. Yet the opposition fires back with chilling warnings. Renowned figures like Stephen Hawking compared SETI to the Aztecs blowing trumpets at Spanish ships, a naive gesture that could invite catastrophe. The risks are stark. An advanced civilization capable of interstellar communication might view us as ants beneath their boots, or worse, resources to exploit. Even if their intentions were benign, the mere act of revealing Earth's location could destabilize global politics, triggering panic or militarization. History offers grim parallels. Indigenous cultures shattered by contact with technologically superior outsiders, ecosystems ravaged by invasive species. The universe, skeptics argue, is no utopia. It's a wilderness where survival favors the cautious. The debate hinges on unknowns we can't resolve. Would a civilization capable of bridging interstellar distances even care about a planet of hairless primates? Some theorists suggest that any society advanced enough to communicate across light years would have moved beyond primitive aggression, perhaps embracing ethical frameworks we can't yet fathom. Others counter that evolution is universal competition for resources. Expansionist impulses might be baked into the fabric of intelligent life, the only certainty. Once a signal is sent, there's no undo button. A message aimed at Sagittarius, even if transmitted today, wouldn't reach the WOW signal's potential origin for another 150 years. By the time a reply could arrive, Earth might be unrecognizable or gone entirely. Ethicists propose middle roads. The SETI Permanent Study Group has drafted protocols for post-detection response, urging international consensus before any transmission. Some suggest passive strategies, leaking radio broadcasts or laser pulses subtly, allowing only nearby civilizations to notice. There's even a fringe idea dubbed stellar dimming, manipulating a star's light with orbital mirrors to signal intelligence without broadcasting our location. But all these solutions share the same flaw. They assume we'd recognize a threat before it's too late. Perhaps the most unsettling scenario isn't hostility, but indifference. The WOW signal, if artificial, might have been a cosmic flare gun shot by a civilization already extinct. Or worse, a message meant for someone else, with Earth as an accidental bystander. In that light, replying seems less like diplomacy and more like shouting into a graveyard. Yet silence carries its own existential weight. If every civilization listens but never speaks, the universe becomes a library where no one dares to turn the page. The clock is ticking. Private initiatives like METI International are already designing new transmissions, bypassing government oversight. As telescopes grow more powerful, the day may come when we detect not just a signal but a pattern, a repeated invitation. When that happens, humanity will face a choice heavier than any in history: to answer or to forever hold our peace. The mystery of the WOW signal might not stay mysterious forever, not with the arsenal of cutting-edge tools now turning their gaze toward the cosmos. At the forefront is the James Webb Space Telescope, a technological marvel that's already rewriting the rules of astronomy. Unlike Hubble, which primarily observed visible light, Webb operates in the infrared spectrum, piercing through cosmic dust to reveal secrets hidden for billions of years. Its unmatched sensitivity could detect biosignatures, chemical fingerprints of life, on exoplanets near the WOW signal's origin point. Imagine Webb identifying oxygen or methane in the atmosphere of a planet orbiting Chi Sagittarii. Suddenly, that enigmatic burst of radio waves would take on thrilling new context, not just a signal but a potential whisper from a living world. But Webb is just the beginning. Upcoming observatories like the Square Kilometre Array, set to come online in the late 2020s, will dwarf all previous radio telescopes combined. With thousands of dishes spanning 2 continents, SKA will scan the sky with 50 times the sensitivity of current arrays, catching whispers 100 times fainter than the WOW signal. Its ability to monitor billions of radio channels simultaneously means it won't just listen, it'll eavesdrop on the entire cosmic conversation. If another signal like WOW drifts in, SKA won't just hear it. It'll dissect its structure, pinpoint its origin to within a fraction of a light year, and track it for weeks instead of seconds. Then there's quantum computing, poised to revolutionize how we sift through cosmic noise. Traditional computers choke on the petabytes of data modern telescopes collect, but quantum machines could analyze it all in real time, spotting patterns no human programmer could anticipate. Google's Quantum AI recently demonstrated this by uncovering hidden correlations in radio telescope data that hinted at previously undetectable phenomena. Apply that to the WOW signal's frequency band, and we might uncover subtle repetitions or encoded structures missed for decades. Even more tantalizing are projects like Breakthrough Starshot, aiming to send microprobes to nearby stars within our lifetime. While not directly tied to the WOW signal, the technology it pioneers, light sails propelled by lasers, could eventually let us study exoplanets up close. Picture a fleet of nanoprobes reaching the Sagittarius region, snapping images of planets that might have hosted the signal source. It sounds like science fiction, but with prototypes already in testing, it's closer than we think. The most radical possibility: we've been searching wrong. Astronomers are now exploring multi-messenger SETI, combining radio data with neutrino detectors, gravitational wave observatories, and even dark matter experiments. If the WOW signal wasn't just a radio blip but part of a broader transmission, a message woven across multiple dimensions, these tools might finally piece it together. The universe's greatest enigmas seldom yield to a single breakthrough. But for the first time since 1977, we're not just waiting for another signal, we're building the keys to understand it. Whether through Webb's infrared eyes, SKA's galactic eavesdropping, or quantum AI's pattern-spotting prowess, the next chapter of this mystery won't just be about hearing the cosmos. It'll be about finally comprehending what it's trying to say. Imagine waking up one morning to headlines screaming that humanity is not alone, that the WOW signal was indeed a message from another civilization. The shockwaves would ripple far beyond astronomy labs and government briefing rooms. They would fracture the very foundations of how we see ourselves. Philosophers have wrestled with this scenario for centuries, but the reality would dwarf all speculation. Carl Sagan once pondered how contact might humble our species, dissolving the illusion that we're the universe's sole actors on a lonely stage. Overnight, every religion would face existential recalibration. Scriptures speaking of humanity as God's chosen creation would collide with proof of other thinking beings, perhaps older, wiser, or utterly alien in their metaphysics. Would faiths adapt, weaving extraterrestrials into their cosmologies, or double down on earthly exclusivity? The Vatican's observatory has already rehearsed this dilemma, with Jesuit astronomers insisting that aliens could be part of divine plan. But not all believers would find comfort in that view. Societies might splinter along new fault lines. Militaries could scramble to reassess threats, while economists might panic over the destabilizing potential of advanced alien technology leaking into our systems. Arthur C. Clarke foresaw this tension, warning that any civilization capable of reaching us would seem like magic or a menace. Governments might hoard contact evidence, fueling conspiracy theories, while corporations race to monetize the revelation. Picture Silicon Valley rebranding itself as the interstellar tech hub, or nations vying to be Earth's diplomatic representative to the stars. The very notion of borders could crumble under the weight of a shared cosmic identity, or harden into paranoid nationalism, with countries accusing each other of colluding with them. Then there's the psychological toll. Humans have always measured their significance against the blank canvas of space. Confirmation of extraterrestrial intelligence would rewrite that narrative in real time. Some might spiral into existential dread, grappling with their newfound smallness in a crowded cosmos. Others could embrace a transcendent unity, seeing humanity as one thread in a vast galactic tapestry. Artists, poets, and musicians would channel this duality, works of despair and awe blooming in equal measure. Even language would strain under the weight. Words like alien and human might shed old meanings, replaced by terms we can't yet conceive. Yet the most profound shift could be epistemological, how we define knowledge itself. A signal decoded might upend our physics, revealing technologies or cosmic truths beyond our theories. Schools would scramble to update textbooks, scientists to abandon cherished paradigms. The greatest discovery in history could also be the most humbling, proof that after millennia of progress, we're still infants in a universe buzzing with voices. The WOW signal's true power might lie not in what it says, but in holding up a mirror to our fragility and our boundless capacity to wonder. The WOW signal isn't alone in the cosmic hall of mysteries. It's part of a growing gallery of celestial oddities that defy easy explanation. Take fast radio bursts, those millisecond flashes of radio energy that erupt with the power of 500 million suns. Like the WOW signal, FRBs arrive without warning, vanish just as quickly, and leave astronomers scratching their heads. Some repeat in patterns, others fire once and never return. The most famous FRB 1212 blazed from a galaxy 3 billion light-years away, its pulse so precise it could have been a cosmic metronome. Sound familiar? The parallels to WOW are uncanny. Both are transient, both are achingly clean in their frequency profiles, and both seem to taunt us with the possibility of engineered origins. Yet while FRBs now have dozens of documented cases, the WOW signal remains stubbornly singular, a one-hit wonder in a universe that apparently loves encores. Then there's Oumuamua, the interstellar visitor that streaked through our solar system in 2017. This tumbling, cigar-shaped object accelerated in ways gravity alone couldn't explain, sparking debates that still rage today. Harvard's Avi Loeb famously suggested it might be artificial, a light sail or probe from another civilization. Critics shot back with theories of hydrogen icebergs or cosmic dust acting like a natural thruster. The controversy mirrors the WOW divide, natural phenomenon or technological artifact. Both mysteries share that tantalizing gap between what we know and what we can imagine. Oumuamua even seemed to pick a perfect exit route, zooming toward Pegasus, a constellation long romanticized in sci-fi as a hub for advanced worlds. Coincidence? Or another cosmic wink, but here's where these mysteries diverge. FRBs and Oumuamua have successors, repeat performances that let scientists test hypotheses. The WOW signal stands apart by refusing to recur, making it both more haunting and less verifiable. It's the difference between finding a single footprint on a beach and discovering a trail leading inland. The others tease us with patterns, WOW taunts us with its loneliness, yet perhaps they're all pieces of the same puzzle. Could FRBs be the universe's natural lighthouses, while signals like WOW are deliberate flares? Might Oumuamua represent the physical artifacts of civilizations that communicate via radio elsewhere? The sheer variety of these anomalies suggests something profound. The cosmos may be stranger than our categories can contain. We're like medieval scholars trying to classify lightning as divine wrath before understanding electricity. What binds these phenomena together isn't just their mystery, but what they reveal about our place in the universe. Each one forces us to confront how little we truly know and how much wonder might still be waiting in the dark. At first, the WOW signal was just a curious footnote buried in an astronomy newsletter, a few dry paragraphs about an anomalous radio burst, filed alongside updates on pulsar research and telescope maintenance. Jerry Ehman's red pen, WOW, might have stayed a private musing if not for a sharp-eyed reporter at Astronomy magazine who spotted the oddity in a routine SETI project update. By early 1978, the story had legs. Mystery signal from outer space baffles scientists. Read one headline, careful to couch the news in cautious jargon. But as the signal's origins remained stubbornly unexplained, media coverage took a sharp turn from sober analysis to speculative frenzy. Tabloids pounced with weekly world news screaming, "Aliens call Earth," scientists too scared to answer. While mainstream outlets played a tense game of telephone, blurring the line between fact and sensationalism, the signal's leap from academic mystery to pop culture phenomenon happened almost overnight. Johnny Carson joked about it on The Tonight Show, pantomiming a panicked astronomer dropping his clipboard. Sci-fi authors spun tales around it. The Atlantic published a breathless essay pondering whether the signal was a cosmic SOS. But beneath the hype, something darker simmered. Conspiracy theorists latched onto the military's quiet interest in the signal, weaving elaborate narratives about government cover-ups. A 1982 New York Times op-ed titled "The Silence from Sagittarius" tapped into Cold War anxieties, suggesting the signal might have been a Soviet space weapon test, despite astronomers' patient explanations that its power dwarfed anything humans could produce. Misinformation spread like wildfire, fed by the signal's resistance to tidy explanations. By the mid-80s, documentaries like the WOW Enigma blended real science with wild speculation, interviewing self-proclaimed exolinguists who claim to decode hidden mathematical axioms in the signal's intensity spikes. Radio hosts amplified these claims, asking listeners, "What aren't they telling us?" The scientific community fought back. Scientific American ran a detailed debunking of the alien Morse code myth, but Nuance struggled to compete with drama. The signal's cultural footprint only grew as technology evolved. Early internet forums in the 1990s birthed persistent myths that the signal repeated in secret NASA recordings it didn't, or that its alphanumeric sequence, 6EQUJ5, spelled a star map. No such pattern exists. When declassified documents revealed the NSA had studied interstellar radio anomalies, conspiracy threads exploded. "They've known for decades," screamed a viral Usenet post, ignoring that the study never mentioned WOW. Yet amid the noise, the signal's true mystery endured. Respected outlets like BBC Horizon and Nova periodically revisited the story, letting astronomers restate the facts. No repeat, no proof of artificial origin, but no convincing natural explanation either. The public's fascination became a Rorschach test. Skeptics saw media gullibility, believers saw institutional close-mindedness, and scientists saw a cautionary tale about how quickly data can spiral into myth. The WOW signal's journey from day to point to cultural icon reveals less about aliens than about us. It's a case study in how modern media metabolizes uncertainty, transforming rigorous science into a canvas for our hopes, fears, and endless appetite for wonder. Every few years, a new generation rediscovers the story, and the cycle begins anew, proof that some mysteries refuse to fade, even when the static does. The WOW signal endures not because we've solved it, but precisely because we haven't. Like a cosmic itch we can't quite scratch, it represents something far bigger than 72 seconds of radio static. It's the embodiment of humanity's oldest question, echoing across the void: are we alone? This singular anomaly, etched onto fading paper in red ink, has become a cultural touchstone precisely by resisting explanation. It's the perfect mystery, neither conclusively natural nor undeniably artificial, hovering in that tantalizing limbo where science and wonder collide. Think of all the astronomical phenomena we've demystified over the decades. Pulsars decoded as spinning neutron stars, quasars revealed as voracious black holes. Yet the WOW signal stubbornly refuses to be categorized, maintaining its enigmatic status like a magician who never reveals the trick. What keeps us returning to this decades-old blip isn't just curiosity, it's hope. In a universe where the laws of physics seem indifferent to life, the signal represents a potential crack in the cosmic silence. Every time a new telescope scans its origin point or a fresh theory emerges, we're not just testing hypotheses, we're renewing a silent pact with the universe, whispering back across the light years, "We're still listening." The signal's power lies in its duality. It's both a scientific anomaly and a cultural Rorschach test. To astronomers, it's a data point begging for context. To dreamers, it's proof we're not shouting into the dark, and to skeptics, an ever-present challenge to keep questioning. This enduring fascination speaks to something primal in the human psyche. Ancient civilizations tracked celestial omens in comet tails and eclipses. We pass radio waves for patterns. The tools have changed, but the longing remains, to find our place in a cosmos that seems alternately empty and brimming with possibility. The WOW signal is our modern-day oracle, offering no answers but keeping the question thrillingly alive. Now it's your turn. We've spent decades analyzing frequencies and debating theories, but some puzzles thrive on collective imagination. Do you think that August night in 1977 marked our first brush with another intelligence, or was it just the universe playing an extraordinary trick? Drop your thoughts below, whether you're Team Natural Phenomenon or Team Cosmic Hello. The conversation is what keeps the mystery burning brighter than any telescope could. After all, the next WOW moment might not come from the stars. but from someone seeing the signal in a new light.